So we're beginning our statistics class with a review of chapter 1, which is just some very basic um, definitions. First of all, notice what is statistics? The science of collecting, organizing, summarizing, and analyzing data. And it should be done for the purpose of answering questions and drawing conclusions. Now, pay attention to these notes because a lot of the notes that I'm giving you, um, there are homework questions that are going to ask you um, about definitions that we discussed here. Statistics allows us to explore things around us, use evidence to check whether our beliefs are true, find patterns to lead to discovery, and share new discoveries with others. Now, statistics must be used carefully. Okay, we see a lot of statistics being thrown at us in our world today, whether it's the spread of a virus or for some political candidate. Um, However, inappropriate results or inappropriate use will always result in inaccurate beliefs, and results are always uncertain. Now we can talk about data analysis. Data analysis is the process of examining collected data to look for patterns, numerical indicators that capture what the data is telling us. And this is really important here. The data sources. A population refers to all data values that will ever occur for a group, such as say this sample of the number of students at a large Valencia college, the population of the number of students, say 23,000 students at one of Valencia's colleges, that would be the population. Now, if I wanted to get data, it's difficult to collect data from 23,000 students. So what we would do is we would select a sample from that population, a subset of the population that represents the population at large. And that's easier to get the information. So say I wanted to survey students at a campus that had 23,000 students. Instead of trying to survey all 23,000 students, I would pick a sample of 100 students and survey those students instead. But that sample has to represent the population. I can't go and pick people from one end of the spectrum or the other, or my data would be not accurate. Now, important here, variables are used to classify data, and variables are characteristics of people or things. And there are two types of variables. One is categorical. Categorical data refers to a quality or class, can be numbers, but no arithmetic possible, such as hair color, zip code, letter grade. Although zip codes and or numbers, you can't do arithmetic with them. So pay attention to this definition of categorical. Now, categorical data is sometimes referred to by different words. Categorical data can sometimes be called qualitative. Qualitative. So if you see qualitative data, it means the same as categorical data. It's describing a quality, okay? And that's where that qualitative comes. Numerical data describes a quantity or measurement, for example, temperature, the height of everyone in our class in inches, or the length of the road that you drove on to get from one place to another. This is described as quantitative data. Comes from quantity, quantitative. Notice the difference in the word. Qualitative describes categories, quantitative describes numbers. I also wanted to mention a couple of things here, and before I actually do some problems, let's see. When you're looking at understanding data, to understand data, you have to ask yourself a few questions. How were the variables measured? What were the variables measured? And who collected the data? Was it somebody who was biased, or was it somebody who tried to be as neutral as possible? Who collected the data? These are three important questions that have to be asked when you consider um, understanding a set of data that's given to you. So next we're going to look at a few of the homework problems. Question is asking, the data were collected from a statistics class. The columns give the variable and each row represents a student in the class. So columns are vertical and the rows, of course, are horizontal. Question is, how many variables are there? It tells us that the column heads give the variables. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. 9 variables. The next question is asking, the data were collected from a statistics class. And it wants to know, is the variable of the age numerical or categorical? So you want to think about age. Age is a number, it's numerical, so obviously it's numerical. And It's because the values are numbers. Okay, if we look at the age column, we see that all of the values are numbers. However, if we were asked the part B, let's say there was a part B of this problem, and it says, is the variable, let's say, handedness, handedness, numerical or categorical? And in this case, if we look at the handedness, we see it describes a quality, whether somebody is left or right-handed. So in this case, it would be categorical because the values are categories. The values are categories. So now we can continue our discussion with regard to, so pause this for a second. So next we're going to talk about storing data or coding data. Coded data is using numbers to record categorical data. And this makes it, reading the data easier. For example, gender becomes female. So for every female, we put one female, 0 would mean male, 1 would mean female, and so on. So if there's a 0, that means it's not a female. Storing data, we have what's called stacked data. Data values stored in a spreadsheet format. Each row contains the data for a single individual. So this would be person X and person Y, person Z, and so on. So each row in this case corresponds to one particular infant. The weight of the infant, whether if the infant is female, they put a 1, and if the mother smoked, 0 would mean the mother did not smoke. In the second case, the birth weight of the infant is 0.88. In this case, 0 would mean that the child is a male because 1 represents female, and 1 would mean that the mother smoked. The mother smokes. Okay. Unstacked data, very different. The values are stored in 2 columns. Each column is a variable from a different group. And notice here, you can only store data for 2 variables. The information does not correspond to the same individual. Okay, and that's pretty obvious because you can't have a man's height and a woman's height being the same. It's not going to be the same person. So here is simply a list of the heights of men and a list of the heights of women. Now, let's look at this problem. It's saying the accompanying data were collected from a statistics class. The columns heads give the variable in each of the rows. So this column head here gives the variables, and then each of the rows represent a student in the class. Okay, so each row here is related to one single student. Suppose you decided to code handedness, whether right-handed or left-handed. Now, key here, use right-handed as the label for the column. So if I'm making up this data here right-handed, or I'm putting, let's say I'm putting handedness, and right-handed would be 1. I'm looking at this column here. I have 1, then a left hand would be 0, right would be 1, then I have 2 lefts, then I have 4 rights, 1, 2, 3, 4. Okay, so everything that's not right-handed would be a 0. So I would have 1, 2, 3, 4, 5, 6 ones, 6 ones, and 3 zeros. Okay, you check 3 and 3, 6 and 3, 9 sets of data to make sure that your data is correct. Now, let's move on here. So this is asking, question continues. This question has a few parts, so we're going to go ahead and take each part here. Researchers conducted a study on brain size as measured by pixels in magnetic resonance MRI scans. The numbers are in hundreds of thousands of pixels. The data provides the sizes of the brain and gender. Compare complete parts A through C. So part A is saying the format of the data, and obviously this data can be regarded as stacked data, right? Stacked data. In part B, what do 1 and 0 represent? So in this case, 1 represents male. Okay, the 1s represent males, and they don't specifically tell you what the 0 is. So if the person is not male, then we're going to assume that the 0s represent female. Female, females. Okay, now continuing this question, if we wanted to unstack this data into 2 columns, part C, unstacked data, we would create a column from female and male, and we would list all of the female data in one column. So 0 has 9.5, 9.6, 9.7, and 9.8. And the male data would be 9.2, 9.4, 9.4 again, 9.8, and 9.9. This would be unstacked data. where we're just listing the brain size of the females and the brain size of the males. So you probably want to check this is 3 into 5 and 4, 9 sets of data. 3 and 3, 6 and 3, 9 sets of data, just to make sure that your data is okay. Okay. All right. Now, we're going to spend a little time here. We'll just continue in our definition in a little bit. So continuing with our discussion, we next want to talk a bit about frequency. Frequency is the number of times a value is observed in a data set. Remember, all these definitions that I'm giving you is going to come back when you do your homework, so you want to pay careful attention to them. Now, moving on here with what we're doing, so here's another problem. A statistics class is made up of 15 men and 19 women. What percentage of the class is male? So part A. First, the total number in the class, male and female, is equal to 15 plus 19, which is 34. So percentage male is 15 over the total of 34 times 100. Calculator. You want to go to your calculator for this. 15 divided by 34 times 100, and round this to one decimal place, so 44.1%. All right, now it tells us a different class has 279 students and 59.1% of them are men. How many men are in the class? So number of men is equal to 59.1% of the total number, 279. So to put that in the calculator, you'd say 0.591 times 279. Calculator, 0.591 times 279. And round it to the nearest whole number, of course, because you're talking about the number of men. So 165 men. In part C, it's saying a different class is made up of 66% women and has 27 women. What is the total number of students in the class? So let's say the total number is equal to x. The way you solve this is you put 100 over 66 is equal to x over 27. X over 27. X on the 100 equated with the 166 equated with the 27. So x, the total number, is equal to 100 times 27 divided by 66. Calculator. 100 times 27 divided by 66. Approximately 41. So 41. Remember, we have to round it up. We have to round up that number because we obviously can't take 40.9 of people. So we have to round it up to the nearest. So 41 students. Okay. Okay, next we're talking about causality and what causes something to happen to be understood in terms of two variables. The treatment variable, whether or not a specified treatment is used for something, and the outcome or the response variable. You'll be asked this question to describe the definition of the response variable. So the outcome variable is sometimes called the response variable. The goal here is to determine if the treatment variable causes a change in the outcome variable. The treatment group receives the treatment or has the characteristics of interest. The control group does not receive the treatment or does not have the characteristics. Visually, this might be, say, a group of people who are trying out a diet pill. And you would have one group, the treatment group, who received the diet pill, and then the control group would be the one who do not receive the diet pill. Other types of studies could be observational studies, where subjects are placed with into different groups by choice. They choose to be there. And anecdotal evidence, a story based on someone else's experience. So I want to discuss one last problem with you in this section. Now, everything that I've discussed here is going to come back in the homework. So please take a good look at this video, keep it open or keep the notes open, and do your homework while you're doing it. This question says a researcher is interested in the effect of music on memory. She randomly divides a group of students into three groups who will listen to quiet music, those who will listen to loud music, and those who will not listen to any music. After the appropriate music is played or not played, she gives the students a memory test. And what kind of experiment in this? Now, this is obviously a controlled experiment, okay? And in this experiment, she's assigning to the students, to the control group at random, okay? She's picking who goes in, who will listen, who will not listen, who will listen to quiet music. So she's assigning them. So this is a controlled experiment. in which the researcher is assigning, physically placing the subjects into different groups by choice. Okay. All right. So this concludes chapter 1, and we're going to close this video now.